Hey, so today we're going to be looking at vector functions. So, um, we first saw vector functions back when we were looking at equations of lines. In that section, we talked about them because we wrote down the equation of a line in R3 in terms of a vector function. In this section, we want to look a little closer at them, and we also want to look at some vector functions in R3 other than lines. Um, we'll look at an ellipse, maybe a circle, a helix. A vector function is a function that takes one or more variables and returns a vector. We'll spend most of this section looking at vector functions of single variables, as most of the places where vector functions show up will be vector functions of single variables. But we'll briefly look at two variables as well. So a vector function of single variable in R2 and R3 have the form vector RT is equal to f of t, g of t, and then also vector R of t, f of t, g of t, h of t, respectively, where f of t, g of t, and h of t are all called component functions. So they're called component functions because they are, normally we call each of those pieces components. So, component functions. The main idea is that we want to discuss in this section is the graphing and identifying the graph. Before we do that, let's look at a problem and talk about the domain. So the domain of the vector function is the set of all of the t's for which the component functions are defined. So I don't think we've really exactly written that yet. So the domain of a vector function is the set of all t's in which all component functions are defined. All right, so we want to determine the domain for vector r of t. We have cosine t natural log of 4 minus t and the square root of t plus 1. All right, so if I'm determining the domain here, I have to ask myself, what can t be? So for the first component, all of the t's can be defined. So That's good. The second component, so for the first one, we're good. For the second one, so we know the natural log, we can only take the natural log of positive numbers. So t has to be greater than 4. And then for the third component, we can only take the square root of 0 or a positive. So that's going to be t has to be greater than or equal to negative 1. And this needs to be t less than 4. My goodness. T has got to be less than 4 because the t comes after 4 minus t, because it has to be above 0. So looking at these limits, we know that the domain can include negative 1, and it can be any number until 4, but cannot include 4. So we can write it like this, or we can say t is between negative 1 and 4. So the domain, you could write it either of this way. This is the largest possible interval. So it has to work for each component. And we talked a little bit about domain before. So now we're going to sketch a couple vector functions. And then we're going to do quite a little bit of different things throughout this. So, okay. So